Some of the examples are explained in this section. The next question is, given the cost function c equal to q cube minus 2q square plus 10q plus 15, find average cost and marginal cost at q equal to 5. Here the total cost function is given as q cube minus 2q square plus 10q plus 15, and find the average cost and marginal cost at 5, q equal to 5. Average cost is total cost by q, that is divide this function by q, and marginal cost is take the differential of this total cost function, that is AC equal to TC by q, that is q cube minus 2q square plus 10q by plus 15 divided by q. Then we will get q square minus 2q square by q is 2q plus 10q by q is 10 plus 15 by q. At q equal to 5, the average cost is substitute q equal to 5 into this function, which will give 5 square minus 2 into 5 plus 10 plus 15 by 5, that equal to 28. Then margin cost is take the first differential of this total cost function, that is given as q cube minus 2q square plus 10q plus 15, that is q cube, differential of q cube is 3q square minus 2q, differential of 2q square is 4q plus differential of 10q is 10 and the differential of 15 is 0. Therefore at q equal to 5, find the value of this, substitute q equal to 5 into the marginal cost function, which will give it as 65. Average cost equal to 28 and marginal cost equal to 65 at q equal to 5. Then another question is, if total cost function is given as c equal to q cube minus 4q square plus 6q, find average cost function, marginal cost function, output at which AC is minimum, find minimum AC, at what level of output MC is minimum, verify that at MC, at minimum AC, AC equal to MC. These are the questions. The total cost function is given as q cube minus 4q square plus 6q. Average cost function is this total cost function divided by q. Then margin cost function is first differential of this function. Find the minimum AC, that is apply the two conditions, first order condition, second order condition. Find the q and check the whether second order condition is satisfied. Then find the value of minimum AC when q equal to the given q at the q. Then find the marginal cost, then find the minimum AC. In this case also apply the two condition, first order, second order. Find the value of q when MC is minimum. Then also see whether when AC is minimum, AC equal to MC. Therefore, the first one is given TC equal to q cube minus 4q square plus 6q. Then average cost equal to TC by q, that equal to q cube minus 4q square plus 6q by q, that equal to q square plus 4q plus 6. This is the average cost. Then marginal cost equal to d by dtc of dq equal to d by dq of q cube minus 4q square plus 6q, that is 3q square minus 8q plus 6. AC is minimum when the first order condition equal to 0. AC is minimum when the first order condition, that is d by dq of AC equal to 0, d square by dq square of AC greater than 0. That d by dq of AC is given as d by dq of AC function is given as q square minus 4q plus q. Then the differential of this is 2q minus 4 equal to 0. Then 2q equal to 4. Therefore q equal to 2. Then check the second order condition, d square by dq square of AC, that is different. Take the differential of this function with respect to q. Then is d by dq of 2q minus 4 is 2. Therefore it is greater than 0. Therefore q equal to 2, or at q equal to 2 AC is minimum, that is both the conditions are satisfied. Minimum AC at q equal to 2 is, substitute q equal to 2 into the AC function. Then we will get the value as 2. Then second order condition. Then the fifth question is find the minimum of AC. First take the first order condition, find the value of q, check the second order condition whether it is greater than 0 or not. the d by dq of MC. MC is given as 3q square minus 8q plus q. That is, the differential of 3q square is 6q minus 8. That equal to differential of 6 is 0. 6q minus 8 equal to 0, or 6q equal to 8, or q equal to 8 by 6 equal to 4 by 3. Then that is q equal to 4 by 3. d square by dq square of MC. That is, take the differential of this function with respect to the q. Then we will get the d square dq of q 6q minus 8 equal to 6. It is greater than 0. Therefore, at q equal to 4 by 3, MC is minimum. Then substitute q equal to 4 by 3 into the MC function. That is, into this function, we will get the value as 0.7. Then third one is, when MC is minimum, MC equal to AC. At q equal to 2, AC must be equal to MC. That is, AC equal to q square minus 4q plus. This is the AC function that we derived. And MC function is 3q square minus 8q plus 6. At q equal to 2. This is the output when AC is minimum. When q equal to 2, substitute q equal to 2 into AC function, that equal to 2. Substitute q equal to 2 into the MC function, that also. Therefore, at q equal to 2, that is, at q equal to 2, AC is minimum. At this output, AC and MC will be equal. Then another question is, the total cost function is given as C equal to 250 plus 0.65x plus 0.02x square for the production of X item. Calculate the size of the daily run that will minimize the cost per item. Find the cost of a day's production for a run but that will maximize. Find the cost of a day's production for a run that minimize the cost per item. That is, the first one is calculate the size of X that will minimize cost per item is AC. The cost per item equal to AC equal to TC by X. That is, AC equal to 200, this total cost function divided by X, that will give 250 by X, that is the whole divided by this, plus 0.65 plus 0.02X. This is the average cost function. Cost per minimum per item is minimized when d by d. They apply the two conditions. D by AC of dq equal to 0, that is AC equal to, this is the AC function, d by dq of AC equal to 0 implies that minus 2, that is 250 by x is the differential equal to, this can be 250 raised to x raised to minus 1, that is minus 1 250 x raised to minus 2. Then we can write minus 250 by x square. Differential of this is 0, differential of 0.02, x is 0.02. That is, this is equal to 0, to minus 250 by x square plus 0.2 equal to 0, that is 2000. We can say that 0.02 equal to 250 by x square, then x square equal to 250 by 0.02, that is x equal to 1000 to 12,500. Then x equal to, x square equal to 12,500, therefore x equal to root of 12,500 equal to 112. The size of daily run which minimize the cost per item is 112. That is, the size of x which will minimize average cost is 112. Then second part is the cost of a daily run which minimize the cost per item is total cost when x equal to 112. That is, total cost at x equal to 12 is, substitute x equal to 12 into the total cost function, that is equal to 573.68. Thus the cost of a day's run which minimize cost per item is 573.68. Here the second order condition is also positive. Another example is given as, given the shortened cost function C equal to q cube minus 7.5 q square plus 15q plus 8, find the level of output at which average variable cost is minimum. ABC is we need to find, and also show that MC equal to ABC at that level of output. Next question is, given the shortened cost function C equal to Q cube minus 7.5 Q square plus 15Q plus 8, find the level of output at which ABC is minimum and also show that MC equal to ABC at that level of output. Here we need to find out the average variable cost and also prove that MC equal to ABC at the minimum of ABC. Here the total cost function is Q cube minus 7.5 Q square plus 15Q plus 8. Here the total variable cost is Q cube minus 7Q square plus 15Q and 8 is the fixed cost. Therefore, TBC equal to Q cube minus 7.5 Q square plus 15Q and ABC equal to TBC by Q. That is, divide this equation by Q, that equal to Q square minus 7.5Q plus 15. Find the minimum of this function. Two conditions must be said that take the first order condition, equate it to 0, find the value of Q. Then see the second order condition, and if it is greater than 0, then the given function is, or the ABC is minimum at this level of output. So let us take the first order condition, d by dq of ABC. This is ABC. Let us take the differential of this function, that is Q square equal to, differential of Q square is 2Q minus differential of 7.5Q is minus 7.5, differential of 15 is 0. Therefore, d by dq of ABC equal to 2Q minus 7.5. That is Q equal to 7.5 divided by 2. That is 3.75. And the second order condition is d square by dq square of ABC. That is 2Q minus, take the differential of 2Q minus 7.5, that is 2, greater than 0. Therefore, at Q equal to 3.75 is ABC is minimum. It is greater than 0. Therefore, Q equal to 3.75 ABC is minimum. Then find the MC, marginal cost. Marginal cost is, take the differential of total cost. That is Q cube minus 7.5 Q square plus 15Q plus 8. That equal to 3Q square minus 7.5 Q square. Differential of 7.5 Q square is 15Q plus differential of 15Q is 15. Differential of 8 is 0. That is, I will get 3Q square minus 15Q plus 15. At Q equal to 3.75 MC. What is the value of MC? That is, substitute 3.75 into this function, we will get 0. At Q equal to 3.75, substitute, find the value of ABC. This equal to 0. Therefore, MC equal to ABC at minimum point of ABC. The next question is, given the cost function C equal to 2 cube minus 15Q square plus 30Q plus 16, show that when output Q equal to 4, AC is minimum and AC equal to MC. Here also we need to find the average cost function and minimum AC and average marginal cost, substitute the value of 4 and see whether it is equal. Average cost function is given as TC by Q, that is 2Q square, that is 2Q cube minus 15Q square plus 30Q plus 16 divided by Q, that is 2Q square minus 15Q plus 30 plus 16 by Q. This is the average cost. AC is minimum when Q equal to 4. We can take the first order condition, second order condition, then we'll get the Q value of this equal to Q square. Q equal to 4. Then at Q equal to 4, we can find the value of AC. Likewise, we can see the function Q equal to 4 into the average cost function, then take the find out the marginal cost function, then find the value of marginal cost function at Q equal to 4. That's therefore at Q equal to 4, marginal cost equal to average cost. Next question is, the total revenue is given as TR equal to 3200 Q minus 6 Q square and total cost TC equal to 90 plus 2Q square. What level of output will maximize the profit? What is the marginal revenue at this level of output? Total revenue is given as TR equal to 3200 Q minus 6 Q square and total cost TC equal to 90 plus 2 Q square. What level of output Q will maximize the profit? What is the marginal revenue? What is the marginal cost at this level of output? What is the maximum level of profit? These are the questions. Marginal, total revenue and total cost are given. Therefore, the marginal cost equal to the differential of this function 4Q. Marginal revenue is differential of this function, that is total revenue 3200 minus 12Q. At this profit maximizing level, marginal revenue will be equal to marginal cost. That is this 3200 minus 12Q will be equal to 4Q. That is 3200 minus 12Q equal to 4Q. Therefore, Q equal to 3200. 4Q plus 12Q equal to 16Q. That is 3Q equal to 3200 by 16, that equal to 200. At Q equal to 200, marginal revenue equal to, substitute the Q equal to 200 into the marginal revenue function. At Q equal to 200, find the marginal cost. At Q equal to 200, find the profit. This will be the profit.